Algebra 2 students, we're going to work on this assignment today. It's going to serve as a review for a test you'll take tomorrow. You can print this from the PDF, or you can take notes on your own paper. You can snap pictures with your phone. However best that you can work with this review. I do want you to realize, though, that most of your test questions will be similar to what you're seeing here. Okay. So the first question says, graph the given set of points and answer the questions that follow. So these points, we have 5, -2. I think I need a little bit smaller dot. What do you think? Let's try that again. That's a little bit too small. Okay, what's the next point? -3, -2. 0, -2. And -2, -2. All right, so there are 4 points. Mine are not very even, but then the first question says identify the domain. The domain for this function, I made it bigger and my graph went away. The domain is the x value. So you can look at your points in the ordered pairs, or you can look at the graph. The domain, ooh, cannot write with that, is 5, -3, 0, and -2. Remember, the domain is the x values. If you have a set of ordered pairs, like in this problem, you only list the x values for the domain. The range, we're going to list the y values. In this case, all the y's are -2. Okay, all the y's are -2. This ought to work. Here we go. Okay, I can put these back in the graph. We had a point there, and a point there, and there, and there. 4 points. 1, 2, 3, 4 points. That's it. Okay, so there's the graph. There's the domain of the x values. The range is the y values. The next question says, is the relation a function? I'm trying to adjust the size here. Give me a little bit of fits so that you can still see everything and I can see well enough to write. Okay, is it a function? Yes. Passes the vertical line test. That means anywhere we draw a vertical line, it only crosses once. Or the x values don't repeat. X does not repeat. That is ugly. Okay. And then the last question says, is it continuous or discrete? How many points do we have? We have 1, 2, 3, 4 points. If you can count the points, it's discrete. Because they are individual points, they're not connected. Okay, individual points, they're not connected. Anytime you have a list of ordered pairs, you're not going to connect those if you can count the number of points, and in this case we had 4. Okay, next. Again, we have a set of ordered pairs. It says graph the given set of points, answer the questions that follow. So our points here are 0, 5, 2, negative 5, 2, positive 5, 4, negative 5, and 4, positive 5. Identify the domain. The domain is the set of all the x values. Since they're ordered pairs, we're just going to list the x's that we have. And those would be 0, 2, and 4. Remember, you only have to, if they're repeated, you only have to list them once. Oh, but they're repeated. That tells us something, doesn't it? Identify the range. What are the y values? 5 and negative 5. Use the relation of function. We talked about a vertical line test. If we were to draw a vertical line here, it crosses through 2 points. If we draw a vertical line here, crosses through 2 points. If we list those points, you notice that the x's repeat. You've got 2 and 2 and 4 and 4. So is this a function? No, it's not, because the x repeats. And is it continuous or discrete? We have 5 individual points. This data is discrete. The only time it's going to be continuous is if it's a line, if the points are connected, or if you have an equation, which would mean the points are connected. Okay. Next problem says provide information about the relation graphed below. Identify the domain, identify the range, continuous or discrete. Is it a function? All right. You'll notice here that these points are connected. What does that tell us? We know that this is discrete. Because the points are connected. Is it a function? Yes, because anywhere you draw a vertical line, it's only going to cross once. Identify the domain. Remember in the practice one, we labeled the points. We need this point that's furthest to the left, which is negative 1, 2, 3, 4. It's negative 4, 4. This one furthest to the right is 1, 2, 3, 4, 1, 2, 3, 4. So 4, negative 4. So the domain, go from left to right, goes from negative 4 to positive 4. All the x's are between. There's a closed circle there and an open circle here. Okay, that's your inequality notation. You could also write this one as negative 4 to positive 4. You could also, yeah, that's going to be about it. Identify the range. We need the lowest to the highest. So it's negative 4 less than y less than or equal to, what's this highest point? 1, 2, 3, 4, 5. You could also write that one as negative 4 to positive 5. You have a parentheses goes with the open circle and a bracket goes with the closed-in circle. Okay? That's 2 different ways to write domain, 2 different ways to write range. If it's a function, tell the intervals where it's increasing and decreasing. Okay, if you look at that graph, in that first part, from where x is negative 4, let me go back to where I can see this. Okay, in this first part of the graph where this is decrease, right? This x value is negative 4, this x value is negative 1. That's a decrease. So let's go back. We have a decrease where that's -4. Where x is between -4 and 1, that's a decrease. That's -1. There's another interval that decreases that starts up here where the x is 1. To down here where the x is 1, 2, 3, 4. Okay. So another decrease from 1 to 4. And then we have an increase, that interval that's in the middle. What are the x values there? -1 to +1. Okay, that's the increase and the decrease. When you're describing this increase and decrease, use the x values. Don't put any lines underneath the symbols. Okay? All right. I'm going to clear those off so it's not so crowded. Let's look at this next one. Provide information about the graph, the relation graph below. Identify the domain. Domain is from left to right. This point that we can label here is 0, 0. And you have arrows on the end. So the domain is x is greater than or equal to 0. Or you could do 0 to infinity. Identify the range. The range, how far down does it go? Well, we've got an arrow that's pointing down. We've got an arrow that's pointing up. So the range is all real numbers, which you can use as fancy capital R. Or you can use a parentheses, negative infinity, to positive infinity, and close. Is it continuous or discrete? You see there are lines there. Those points are connected, so this is continuous because the points are connected. If you see a line or a smooth curve, if the points are connected, that's continuous. Is it a function? Is it? What happens if we draw a vertical line? Crosses twice. So no, it doesn't pass the vertical line test. If you were to list the points like where x is 1, you got a point right there and a point right there. Where x is 2, you got a point right there and a point right there, so the x repeats. If it's a function, tell where the intervals where it's increasing and decreasing. It's not a function, so we can't tell increasing and decreasing. All right. Very good. On these two, it says for each given equation, develop a table of values to produce a graph and answer the questions that follow. Do you remember we did these on the calculator? So we can open a tab that says desmos.com. The first equation is, change my page right here. 8 times 1/2 raised to the power of x. 8 times 1/2 raised to the power of, that's shift 6 to the power of x. Okay, so there's the graph that you can sketch on your paper. Do you remember from Desmos how to get the table? You click the gear and the table. And if you're working on a problem and you don't have the numbers that show up in this table that you need, you can just type the numbers. So we need -1, we have that one. 0, 1, 2, we need 3, 4, 5, and 6. So I'm going to come right here and type 3. And since they're going consecutive numbers, we can just hit enter. 4, 5, 6. And there's our table. And there's our graph. Okay, let's go back to our paper. And here's the table. Where x is -1, y was 16. Where x is 0, y was 8. Where x is 1, y was 4, 2, 1, 0.5, 0.25, and 0.125. Can you see what's happening here? 16 to 8 to 4 to 2 to 1. It's decreasing. It's decreasing by half. So I'm trying to. Okay, there's the table. And the way I have this page set up, maybe. No, it's not going to let me do anything until I erase that. Okay, here's the graph. This is where I hope you have it written down somewhere or take a picture of it. We had -1 and 16, 0 and 8, 1 and 4, 2 and 2, 3 and 1. It gets really, really close. We go like 0.25 and 0.125. Remember I told you that if they give you an equation that you would go ahead and connect these points. This is exponential decrease as far as a function goes. The domain and range. The domain, I'm going to write it up here. Is all real numbers because it has arrows both sides, left and right. The range. Say it gets close to 0 but doesn't touch it. Y is greater than or equal to 0, or you could write it with a bracket and a 0 to infinity. That's the domain and range. What's this one doing, increasing or decreasing? If you read it from left to right, it is decreasing. Is it continuous or discrete? When we have an equation, it is continuous. Points are connected. And the parent function is exponential. It's just going down instead of up. Okay. All right. Let's get rid of that. Go to the other side. Okay, for each equation, develop a table of values to produce a graph. I didn't read that correctly. For the given equation, develop a table of values to produce a graph. Answer the questions that follow. So let's go back to Desmos. You might notice when you see that 12 over x that there's a fraction and the variable is in the denominator. That tells you right off the bat that it's a reciprocal function or a rational function. When you graph it, you see the two branches or the two parts. We have a horizontal asymptote or a line that doesn't approaches but doesn't touch. A vertical asymptote. Let's go look at the table. Our table on our paper starts with -6. I don't think we can put one up above it. But we can type in -6, -4, -3, and we have -2 and 0. Notice that 0, 2, 3. So we need 3. This is going to be a little bit out of order from your paper, but it's okay. And 6. If you notice that the 0 that it says undefined, what happens in that graph right here where x is 0 doesn't touch? This is a horizontal asymptote. And this is a vertical asymptote. Those are lines that the graph approaches but doesn't touch. Okay, that's the graph. Let's go back to the paper. Here is your table. It would be -2, -3. Sorry, this is not writing very well. So do a little better. -2, -3, -4, -6, undefined, which means the graph doesn't touch there. 6, 4, 3, 2. There's your table. We could go back the old-fashioned way before we had graphing calculators, and we would just do 12 divided by -6, get -2, 12 divided by -4, -3, 12 divided by -3, and so on. All right, let's look at your graph. That graph ended up, we had 2, 6, 3, 4. I keep looking to the side because that's where my answer key is, because I can't see everything. I guess I could look here. 4, 3, 6, 2. Because we have an equation, it was continuous, so we connect it. The negative parts that we had were -6, -2, -4, -3, -3, -4, and -2, -6. So it's just the reflection or the mirror image there. There's your graph. This is, it says identify the domain and range. I'm going to move it up. Or I can write it off to the side. Something you see a little better. The domain for this one, it touches everywhere except where x is 0. Because you have negative x values over here and positive x values over here. The range, it touches everywhere except where y equals 0. Okay. Increasing or decreasing, if you notice, this branch is, if you go left to right, is going down. This top branch, if you go from left to right, it's going down. So it's decreasing in both. So you can just put decreasing. Continuous or discrete, because we have an equation, we know to connect the points. So it's continuous because the points are connected. And what parent function? It's the rational parent function or the reciprocal. You can recognize that from the equation because it has a variable in the denominator, and you can recognize it from the graph because it has two parts. Okay? All right. This says, if f of x equals 5x minus 3 and g of x equals x squared plus x minus 2, evaluate the following. This is function notation. And we're going to plug these numbers in. We're going to distinguish between the two functions by naming one of them f and one of them g. Number 7 says f of 4. So we're going to find the function that's labeled f. And we're going to take that 4 and plug it in for the x. Plug the x in, right? Plug the 4 in right there. 5 times 4 is 20. 20 minus 3 is 17. Move to number 8. You have g of negative 2. Find the function that's labeled g or named g and take that negative 2 and plug it in for the x. So you have negative 2 squared plus a negative 2 minus 2. I think they could come up with another number, right? You can tell I'm out of practice writing with the stylus. That's kind of ugly. This is negative 2. Remember when you use your calculator, you have to put that negative 2 in parentheses. So that's 4 plus a negative 2, so minus 2 minus 2, which is 0. So g of negative 2 equals 0. F of 3/5. We're going to find that function that's labeled f. I'm going to plug that in. So we have 5, replace the x with 3/5, minus 3. These 5's cancel. Guess what 3 minus 3 is? 0. And then g of a minus 1, we had one like this the other day. We're going to take this function that's labeled g and we're going to do a minus 1 squared plus a minus 1 minus 2. A minus 1 squared, let's do this. Change the background a second. This a minus 1 squared is a minus 1 times a minus 1. That's this. Then we have plus a minus 1 minus 2. You can multiply these a minus 1's together. You can use FOIL or you can use box. We have a squared minus a minus another a plus 1 plus a minus 1 minus 2. Combine your like terms. Here's an a squared. There's minus a plus a. Those two would cancel. And you have plus 1 minus 2. You remember box method? We had a minus 1 and a minus 1. So you have a squared minus a plus 1. Okay, that's box method. All right. Okay, actually, yeah, let's keep going. I thought we might stop, but we're going to keep going. A survey was taken to collect data on the vehicles per household as related to the number of persons in the household. The data were collected in the table below. So what are we comparing? The number of people and the number of vehicles. Use the data to create a scatter plot. Do you think this is going to be a function? Does the number of people in the household determine how many cars we have? Use the data to create a scatter plot. Is it a function? Is it discrete or continuous? Okay, so let's look at our scatter plot. So 2 people, 3 vehicles. 3 and 6. 6 and 2. 5 and 3. 4 and 7. 4 people, 7 vehicles. Good grief. 3, 3. 1, 1. 2, 1. 4, 2. And 5, 2. So there's the graph. Take a minute, look at that and see what do you notice. Is there any correlation? Does it go up? Does it go down? Are they all over the place? There's really no correlation. Those are kind of scattered. There's You really can't predict the number of vehicles by the number of people according to this data. Does it describe a functional relationship? How do we know if it's a function? Do the x's repeat? Did we have the same number of people? I see a 3 right there and a 3 right there. I see a 4 right there and a 4 right there and a 5 and a 5. This is not a function. Well, you could also look at the graph and notice that if you draw a vertical line here, it's going to cross twice. Here it's going to cross twice. Here it's going to cross twice. So it fails the vertical line test is another way. Is it discrete or continuous? We talked about continuous being able to use fractions and decimals for both sets of data. Can we use fractions and decimals for the number of people or the number of vehicles? No, those dots are not connected. Now I drew vertical lines to check for function, but they're not connected. We can't have 1.3 cars. We can't have 2.6 people. This is discrete. Could the data be used to make predictions? Based on this set of data, can we predict how many vehicles will be by the number of people? No. There's no pattern. No correlation. Okay? All right. One more problem and we're done. The following data comparing the mean height, mean is average, of children in relation to their age was collected in Kalama, Egypt. Plot the data, answer the questions that follow. All right. Here we go with our little graphing. And these are going to be estimates. It's going to be hard to be precise with 76.1 and 78.1 and that. So we got 18, 76, 19 and 77, 20 and 78.1. You can fast forward here a little bit if you want to. Until I get it graph 21, 78.2, 22, 78.8, 23, 79.7, which is almost 80, 24 and 80, almost 80 again, 25 and 81, 26 and 81.2, 27, 81.8, 82.8, 83.5. Okay, there's an approximation of that data. Is it a function? What are the x values here? The x values is the age in months. Did those repeat? 18, 19, 20, 21, 22, 23, 24, 25. No, they didn't repeat. So yes, it's a function. No x repeats. And I wrote with my graphing tool. That's okay. All right. If it's a function, identify increasing or decreasing intervals. It was not a function. Oh, it was a function, wasn't it? Think back to that graph. What was it doing? Sorry, it was a function. Increasing intervals. It was increasing pretty much, wasn't it? There was never a whole section of that graph that went down. Next question, write a sentence to describe the domain and range of the problem situation. The domain was the age. Oh. The domain is from 18 to 29 months. The range. What were the heights? 76 to 83. Centimeters. So I put inches, but they were working in Egypt. Everything's going to be in centimeters. Predict the mean height of a 21.5-month-old baby. So look back at your graph. 21.5 is between 21 and 22. So that's between 78.2 and 78.8. Could you predict the height of a 21-year-old? Now think about, let's go back to that table. All of those are months. Think about a child 18 months old. It's a toddler. 29 months old is a little bit more than 2. It's like almost 2.5. Is that child going to continue growing at that same rate? Do you grow as fast from 8 to 9 as you did from a 1.5 to 2.5? No, then you have another growth spurt when you're a teenager. But then do you grow, what did they say, a 21-year-old? If we use this pattern and we take it all the way through to a 21-year-old, they'd be like 8.5 feet tall. So no, you can't use this to predict the height of a 21-year-old because your growth rate slows down. All right, that's it. Good luck on your test.